Hello guys, in this video I am going to explain the solution of this question number 47 of chapter 11 of the book Engineering Circuit Analysis by Hayt, Kemmerly and Dermot. So the question says that for this particular circuit we need to determine the complex power delivered to each passive components of the circuit shown in this, and we also need to determine the power factor of the source. So for all these components we need to determine the power delivered and also the power factor of this source. So to solve this particular circuit, simply what we are going to do, we are going to first of all we are going to determine the currents. So for the current we can just simply use any theorem. So let me use the mesh analysis. Okay, we can use the nodal analysis or any other way, like we can go with it. Why? Because we have the impedances which are in ohms, so simply we can apply the mesh analysis. So if I apply the mesh analysis for this particular loop, right, for the I1, I will get the equation as minus to plus. If I take minus to plus as negative, so minus 50 angle minus 17 degree is plus. Now the current is flowing in this direction, plus minus, so it will be J30 into I1, right? And now over here there are two currents, I1 is coming down, I2 is coming up, right? So I overall current will be I1 minus I2 and plus minus. Why I1 minus I2? Because we have assumed that this current is coming down. So plus it is 10 ohms. So 10 I1 minus I2 equal to 0. Right? So this is first equation. Now similarly following the same thing for the second loop. Now over here, if starting from here, if I take the current as this, now over here one current is I2 that is going in the same direction and I1 is going in a different direction. So this, if I consider the arrow in the upward direction, then it will be I2 minus I1, right? So I2 minus I1, and the resistance is 10, so it is 10 plus, going over here, plus minus, and the current is only one I2, so it will be minus 25J, minus J25 I2, right? J25 I2. And then over here coming down, so it is plus, this is minus, so plus minus, it is plus 15 I2 equal to 0. So these are the two equations, and if you solve these two equations, like how you will solve, like over here, if you look at the second equation, like 1 and 2, so over here if we solve the 2, we will get, like, we can rearrange, like all the I2 I can bring on one side and all the I1 on the other side, so we will get 10 I1, because only one I1 is there and all the remaining are I2. So 10 I1 will be equals to, over here, 10 I2 plus 15 I2. So it is 25 I2, right? Just a minute, yes, 2.5. Okay, just let me check if I have done everything correctly. Yes, so it is 25 I2, and then this is minus 25J I2, or I can take this as common, removing I2. So this will be this I will get from the second equation, right? And now substituting the second equation in equation 1, what we can get, like we can get 15, taking this, bringing this on the left hand side, so 15 minus 17, it is equals to, we have this I1 and I2, this is I1 and this is also I1, so we can write it as 10 plus 30j I1 and then minus 10 I2. Now this can further be written in this way, like 1 plus 3j 10 I1 minus 10 I2. Now substituting this value of 10 I1, this is 10 I1, right? So substituting the value of this 10 I1, we will get 1 plus 3j 10 I1 is 25 minus 25j I2 minus 10 I2, right? And now this over here you can solve it in any way, right? You can convert this and this into the polar form and then uh, multiply and then again come back to the complex form. So anyway, so let me try with or I2. We can take I2 as common, so minus 10 I2, right? So, so it is 25 and within the bracket we will get like 1 plus 3j minus j and 1 plus 3j minus j, yes, minus j, and it is minus 3j square minus 10 I2. It is 50 angle minus 17. So it is 25 and this is 1. Now this j square is minus 1, right? So this will become plus 3. So plus 3 and this one will make it 4 and this is plus 2j, right? Minus 10 I2. So it will be like 100 plus 50j minus 10 I2. So this is 90 plus 50j I2 and this is 50 angle minus 17, right? And now to get the value of I2, what we can do, we can convert this into the polar form, right? So we can convert this into the polar form and then we can divide it with this. So we will get something as, just a minute, 5, okay, so 5. Just let me check if I have done all the things correctly. Okay, yes. So I can also write it as like this, angle 17 and dividing this complete thing with 50. So I will get 90 divided by 50 plus 50j I2, right? And this 90 by 50 can be replaced with 1.8 plus, sorry, not 50j, it will be only j. It will be only j plus j I2. So we can convert this into the polar form. So it will be minus 17 equals to 2.06 angle 29.05 I2. So our I2, it will be this angle minus 17 divided by 2.06 29.05. So we will get our I2, or let me put in the next line, our I2, it will be 0. for 0.485 angle minus 46.05 amperes. Once we get I2, now from this, substituting this I2 in the above equation, like we can substitute this I2 in this third equation, which is 10I1. 10I1 equals to 25. So we know then 10I1 is equals to 25 minus 25J I2. So substituting this value of I2 over here, we will get I1 as 1.715, or let me show you the complete calculation just to avoid any confusion. So it will be 25 I minus J, and this is I2 is 0.485 minus 46.05, right? Now this 25, this I minus J, it can be converted into the polar form, and in polar form it will be root 2, angle is 45, right, into 0.485, angle is minus 46. It angle over here, the angle will be minus 45, okay. So it will be minus 46.05. Now this solving this, and this is 10I1. So solving this for I1, we will get the answer as 1.715, angle is minus 91.05 amperes, right? So this is our I1. Now coming back to the circuit, let me put my I1 and I2 value over here. I1 we got as 1.715, angle is minus 91.05 degrees. I2 I got as 0.485, angle is minus 46.05. Now from this we can also determine the current, this current flowing through this 10 ampere, right, 10 ohm. So this will be, if we take the direction of the current in the downward direction, so this will be I1 minus I2, right? So since we got the I1 and I2, so we can determine I1 minus I2 will be, like, if you solve this, you will get the answer is 1.416, angle will be minus 105.54 amperes, right? So to get the I1 minus I2, first of all you need to convert this into the complex form, means A plus Bj, and then you will subtract the two complex number, and then after getting the result of the subtraction, again you need to convert that complex form into the polar form to get this answer. Now once we get this I1, I2 and the current flowing through this 10 ohm, now you can see that I1, the current flowing through this, it is I1. The current flowing through this, it is I2, and from this it is I1 minus I2. So we are able to get all the currents, right? And once we are able to get all the currents, it means we can simply, by multiplying I into this, we will be able to get all the voltages, right? So let me write the voltage and the current as per the elements. So I J30, ij30 current is I1, so it is 1 point. Let me use another ink. So ij30, it is equals to I1, so it is 1.715. Angle is minus 91.05 degree amperes. Then Vj30. Now this Vj30 with plus and minus over here. This will be this ij30 into j30 into ij30, right? And this j30, it can be written as this 30 angle 90, right? Angle 90 into ij30 is 1.715 in angle 91.05, right? So this Vj30, it will be equals to 51.45, angle is minus 1.05 degree, right? Now coming to this j minus j25, current flowing through is I2, right? So it means I, let me use another one, I minus j25, it is equals to I2, so it is 0.485, angle is minus 46.05 amperes. This is volt, right? So now V minus j25, it will be this current into minus j25 into I minus j25, right? Now minus j25, again it can be written as, because it is minus, so it will be angle minus 90 into I minus j25. So if you solve this, you will get the answer as 12.1, angle is minus 136.05, right? Now coming to this 15 I2 current is flowing, so I15 I2 current is flowing, I2 is this 0.485, so 0.485 angle minus 46.05 amperes. Voltage, it will be simply 15 into I15, so we will get answer is 7.275, angle is same, minus 46.05, right? Now the last one, it is this 10 ohm, and the current flowing through this 10 ohm, it is I1 minus I2, right, which is this. So over here 1.416, so I10, it is current flowing through this I10, it is 1.416, angle is 105.54, right? And amperes, and the voltage, it will be 10 into I10, so it will be 14.16, and angle remain same, right? It is volt. Now once we get all the current in the voltage, now coming back to the question says that we need to determine the complex power delivered to each components. So we know that complex power, it is represented as S, and it is P plus JQ. And what is P? P is V effective V effective means Vrms, I RMS or I effective into cos theta, which is the power factor or the phase difference between the voltage and the current, plus V effective I effective sin theta, right? So means V effective I effective. Now we already know all the current and the voltage, and if you look at this is our Im, this is our Vm, because we know that this V10 or I10 can be represented, it can be written as 1.416 cos omega t minus 105.54. This we know, right? So this is our Im, right? And we know that I RMS or I effective, it can be determined as Vm upon root 2. Okay, Im upon root 2, right? So over here we know Im upon root 2. So since the formula in the complex power it is V effective into I effective, so that same formula, this same formula, it can also be like over here, if I write, it can also be Vm Im by 2 cos theta plus Vm Im upon 2 sin theta. So I will use this formula because I know what is Im and what is Vm, right? So now writing the complex power. So if I write the complex power, so it will be, let me erase this and let me write it over here. So for this, for J30, it will be S J30, and this is my Im, this is my Vm. So 1.715 into 51.45 upon 2. Okay, so this will be my upon 2. And what is the phase difference between the voltage and the current? Now the phase difference between the voltage and the current is, if you look at this is, this angle is 91.05, this is minus 1.05. So if you take the difference of this, you will get 90. So this will be cos 90 plus again 1.715 into 51.45 upon 2 sine 90. Now due to this cos 90, this is going to cancel out, so we will get only sine 90 expression. So this is 1, right? This is 1, and also j over here we have j also. So at the top I have forgot this is j, right? Over here I have mentioned j, right? So we will get, it means for this SJ30 we will get only imaginary part, and this imaginary part, just a minute, it is 17.64. Just a minute, let me check if I did all the things correctly. E30 51.05, 51.405, and IJ30, it is, just a minute, this is right, this is right, yes. So 1.715, okay, I need to calculate this. Oh, okay, so it will be like, I need to calculate this, so this will be 1.715 into 51.45 divided by 2, so it will be 44.12, right? So this is the power that we go imaginary, not only. Now similarly, for the next part, for this one, again we will write the same formula, s minus j 25. So it will be Im is this and Vm is this. So 0.485 into 12.1 upon 2 cos theta. Theta, the angle between this current and this voltage. So if you take the difference between these two, again you will get a 90. So sine cos 90. And again over here also remember that that when we take this cos theta, then voltage is in leading, right? So over here in the first case when I did, so over here the voltage, it is angle is minus 1.05 and the current angle it is minus 91. So we will always take the angle, like first we will take the angle of voltage, then the angle of current, because this cos theta, it is written in such a way that the voltage is leading, right? So we always take the subtraction of the voltage angle minus current angle, right? So now over here in this case, voltage angle is minus 136, current angle is minus 46. So the angle, it will be minus 90, not plus 90, minus 90. And now over here plus j, it will be again 0.485 into 12.1 upon 2, and it will be sine minus 90, right? So this will cancel out, due to this it becomes 0, right? So we will get only this expression. So this will be 5.86 minus 5.86 minus 5.8685 j. Right, now coming to the third one, the I5, complex power of I5. So it is S15. So again Im and Vm, so we get 0.485 into 7.275 upon 2, and now the angle between the voltage and the current, since it is the resistance, so it is 0 degree. So it is cos 0 plus j 0.485 into 7.25, and since sine 0 is 0, so we get only the real component, and it will be our S15, it will be 3.528 watt. And the last one, the 10, over here S10, again Im and this is Vm. So 1.416 into 14.16 upon 2 cos. Now the angle, because it is the resistance, so angle is between the voltage and the current, it is 0. So plus j 1.416 into 14.16 upon 2 sine 0 equals to so it will be S10, it will be 20.05. So these are the 4 complex powers. Right, now coming back to the question. So the question says that we need to determine the complex power delivered to each component. This we have calculated, and the next question is that we need to determine the power factor. We need to determine the power factor of the source. Now for the source, the current flowing through this, it is I1. Okay, so the current delivered by the source, it is I1. I1 is this, right? So What is power factor? Power factor, just a minute. Yes. So power factor, it is cos theta. And what is theta? Theta is the angle between the voltage and the current, with voltage leading the current. So it means voltage angle of phase of voltage minus phase of current. So over here, the phase of voltage is minus 17 and the phase of current is 91. So we will write it as cos theta. So it is minus 17 minus 91, right? So we will get this as cos 74 degree, and cos 74 you will find it as. So this is our power factor. This is our power factor, the answer to the second part of the question. So with this I end this video. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.